Hello all, in this lesson we're going to be studying concentration. We're going to do two in particular, percent by mass and molarity. The homework for this lesson, which will be the header of your classwork page for the day, is right here. Copy that down. It'll be due in a couple of class periods. And this is fun. Let me fix this. All right, back to it. But today's aim is what is concentration, day one. Copy down these do now questions with this corrected graph, and we will answer them in class tomorrow as they're due now. All right, concentration. Solutions are always homogeneous mixtures, but their compositions can vary. For instance, check out these two ridiculous examples. First of all, these are not solutions. I was just in a bubble tea phase when I made this, but if you had 20 bubbles in 1 liter of tea, that would be a lot of bubbles for a tea. We would say this is more concentrated. If you had only 2 bubbles in a liter of tea, that's a lot fewer bubbles. We would call that dilute. So dilute and concentrated are qualitative terms that describe the level of concentration of a substance, but they're really only able to be used to compare one to the other. So if we just think about these as ratios, then dilute would be having relatively less solute per unit of solvent, and concentrated would be having relatively more solute per unit of solvent. Concentration in general should just be thought of as a ratio that describes the amount of solute and the amount of solvent. And there are many different ways to actually describe concentration, and I'm only going to teach you 2 today. I'll teach you several more tomorrow. Percent by mass is probably the least commonly used concentration description method, but it happens every now and then. Please just bear with me on this. I'll tell you how to do it and we'll move on. So the way you do it is you just take the mass of the part and you divide it by the mass of the whole and you multiply by 100. This is actually on your reference table on the back, table T. Let's practice. What is the percent mass of sodium hydroxide if 2.5 grams of sodium hydroxide are added to 50 grams of water? So following the formula, the mass of the part here is 2.5 grams of NaOH. And the mass of the whole is 50. Or is it? So I'm going to cross this out and tell you right now that there is some reading comprehension involved in this, because it says the mass of the whole is what we're looking for, rather than the mass of the water, which was 50. The whole thing would be the solution, which would be the water and the sodium hydroxide. So I'm going to write, instead of 50, 52.50 grams of solution. So once we have that, we multiply by 100 to get. So I got 4.76%. With sig figs, I should really only keep 2. So, of course, 4.8% is probably the better answer, but both would be acceptable. But now this guy's the real deal, molarity. Everybody uses molarity to explain concentration. This is by far the most important one, so pay attention. The way we do this is surprisingly strict. Molarity is calculated by taking the moles of solute, specifically moles, not grams, nothing else. It has to be the moles of solute. And we divide it by the liters of solution. Now this is all kinds of tricky, so I hope your brain is turned on. So moles of solute, oftentimes we'll have to take a mass of solute and convert it into moles before we can find this part. Sometimes they'll be nice enough to give us the moles directly. Other times we'll have to do it ourselves. The liters of solution, that's tricky too, because a lot of times they'll say how much water you have, but really in truth you should be paying attention to the solution. So it's not how much water, it would be how much solution. Let's do an example. Now admittedly this is an easy example. It's very straightforward. What is the molarity of a solution that contains 4 moles of sodium hydroxide in half a liter of solution? So according to the equation, molarity, or a capital M, is the moles of solute or the liters of solution. So let's start out by writing that. Moles over liters. So the moles, it said in the question, was 4 moles, 4.0, and the liters it said was 0.5. So do a quick calculation on that, and you'll find that the molarity is 8 molar. One thing I would like to point out is that 8 molar would mean, at least for a 1 liter solution, it would mean that you have 8 moles of solute in the 1 liter of solution. That's what this capital M, it means moles per liter. So that would mean 8 moles per liter. But we only have half a liter, which is why it makes sense that we had 4 moles, because those proportions would stay the same. 8 moles for 1 liter, 4 moles for half a liter, 16 moles for 2 liters. But when you do the ratio, it's always going to come out the same, 8 to 1. So you can do some stoichiometry with concentration as well. Or you can do everything in 2 steps. Tomorrow I will do probably a little bit more of the 2-step method, but today I would like to show you guys the more advanced method. So in the previous question, we had just decided that the concentration of the solution was 8 molar. So keep in mind that the symbol M represents moles per liter. Therefore, a liter of the solution would contain 8 moles. But what if we had a different kind of question, like this one? What is the molarity of a solution containing 82 grams? So this is automatically different because it's not moles. Containing 82 grams of calcium nitrate in 2 liters of solution. We want to know what units we have and what units we want. So right now we have grams and we also have liters. I'm just getting that from the questions here. But the units that we want ultimately are molarity, or moles per liter. So let's set up a grid with given information. The given information is going to be 82 grams of calcium nitrate. All right, so we're going to multiply this by a conversion factor. Now the bottom, or the denominator of this conversion factor really needs to have grams in it, because we're going to cancel the grams out, because we don't want this guy anymore, we want this guy, we want moles. So I put grams in the denominator and I'll put moles in the numerator, because grams per mole is a gram formula mass. And we can easily find the gram formula mass of calcium nitrate with just some basic chemistry skills. I'll set up a table for that now. So I've started it. I put in the masses of the calcium, the nitrogen, and the oxygen. I need to put in the quantities though and multiply. So I got these values. Now I need to add them together. So a 40, a 28, and a 96 comes out to 164 grams per mole. So we fill it in like this. 164 grams, 1 mole. Now when we do that, we're going to be able to get rid of the grams, and our answer will come out as moles. We can go ahead and do that now. 82 divided by 164 is going to be 0.50 moles. So that means I have just half of a mole of the calcium nitrate. But they actually want to know the molarity, if I remember correctly. Yes, what is the molarity? So a molarity is moles per liter. So I'll do this in the last part of the question. And the number of moles we just solved for is 0.50 moles. And the liters we just solved for as well, it's 2 liters. So 0.5 divided by 2 is 0.25 molar. Final answer. And with that, we've reached the pair up. So copy down these guys. We'll solve them in class tomorrow. And follow them up with these guys, which we'll also answer in class tomorrow. This was a really hard lesson. I hope you understood it, though. And I'll see you in class tomorrow. We'll talk about everything. Have a good night, and thanks for watching.